Everyone, this is Anurag, Associate Professor in EC Department of BVC Engineering College, Vadalrevu, Andhra Pradesh. Today, I am going to discuss about pulse modulation techniques. So this is the next stage of modulation techniques. In the previous class, we have learned about a basic type of modulation techniques which is basically used in any communication system. So instead of using a continuous carrier and a continuous message signal, we are going to make use of pulsated signal as a carrier signal in this pulse modulation techniques. And these pulse modulation schemes are classified into two different types: analog pulse modulation and digital pulse modulation schemes. Coming to this analog pulse modulation system, in this both the message signal and carrier signal is a analog signal, and this is classified into three types: pulse amplitude modulation, pulse width modulation, pulse position modulation. And coming to digital pulse modulation schemes, it is of two different types: pulse code modulation and delta modulation schemes. So the basic advantage or the primary advantage of using this pulse modulation scheme over a continuous wave modulation is that instead of using a continuous wave, or instead of transmitting a continuous wave, it requires more power. So the power requirement is less in pulse modulation schemes, and the vacant time between pulse to pulse can be used for another signal can be transmitted, such as, that is, it can imply a time division multiplexing scheme, so the channel can be utilized in an efficient manner. Let us discuss the basic types of an analog pulse modulation schemes in the classes. Coming to the first type is pulse amplitude modulation. It is generally called as an PAM. As the name itself defines that the amplitude of the pulse is going to be vary in accordance with the instantaneous values of the message signal. Here the message signal is a continuous signal, and based on the amplitude of this message signal, the amplitude of pulse will be varied. If the amplitude of message signal is high, the pulse will be having a higher amplitude in a PAM wave, and similarly at the point where the amplitude of message signal is less, the amplitude of pulse will be minimum. In these PAM systems, the width and the position of this pulse will remain constant. There will be change only in the amplitude of pulse. There will not be any change in the width and position of a pulse signal. And this PAM could be implemented in two different ways. One is single polarity PAM, where in this single polarity PAM it consists of a fixed DC bias which is added to the signal, so that every pulse which is generated at any point will be above this fixed DC point. Let us consider a signal consisting of only positive pulses, which is shown in the diagram. A unipolar, it is also called as an unipolar PAM. That means only one polarity will be present. All the pulses will be in the positive direction. Second type is double polarity PAM. It can make use of both the positive and negative pulses. So we can see in the second diagram, the amplitude of the pulse is going to be varied according to the message signal, where it can have both positive and negative pulses. These are the two basic types of an pulse amplitude modulation techniques can be implemented. And here it is the graph or model waveforms, how an continuous pulse signal is going to be varied. Here we can see the model waveform to implement pulse amplitude modulation. The first figure indicates the modulating signal, which is a continuous signal, and the second one is a carrier signal, which is a pulsated signal. And if we implement a pulse amplitude modulation for these two, message signal and a carrier signal, we can obtain a PAM signal, which is shown in the third figure. So here the envelope of PAM output is same as the envelope of a message signal. So it is also called as a natural pulse amplitude modulated wave. If we change the envelope of pulsator, that is the top shape of every pulse is kept into an or is obtained into an flat signal, then it produces a flat top PAM signal. So this is about the PAM modulation wave, how can be represented. So depending upon the type of sampling, the PAM can be done with the help of an ideal sampling PAM or natural sampling PAM and flat top sampling. That's what the basic diagrammatical representation shown in the previous windows images. So the advantage of this modulation scheme is that the generation and detection is easy in this modulation and it allows multiplexing. And the disadvantage is it is going to make use of larger transmission bandwidth or large bandwidth can be used. So here this slide shows the PAM signal which is produced with the help of a natural sampling, follows the same shape of an input signal. Here the PAM signal can be generated by using a pulse signal or carrier signal is called as a sampling signal, and the frequency of this is called as a clock frequency, which can be operated with the help of an electronic switch or a chopper. It produces a sample of analog message signal. If the switch is closed for a duration of each pulse, when the pulse signal is on, the switch will be in the closed position, so that it allows the message signal will be passed through the switch, which can be taken at the output side. And for the remaining duration of an pulsated signal, when it is in off position or during the second half cycle of an pulsated signal, the switch will be in an off position, so that the output will become 0, and it is called as a natural PAM signal. Whereas the flat top sampling signal can be produced with the help of a sampling and hold circuit, which is connected with the chopper. So what happens in case of this sample and hold circuit is that the output of the chopper will be held by the sample and hold circuit, so that the amplitude of this pulse will be maintained at a constant level during the sampling time. And flat top sampling produces the pulsated signal whose amplitude is fixed for some duration of a sampling signal. The amplitude value depends upon the amplitude of the input signal at the time of sampling. The basic disadvantage in case of this PAM is aperture effect is seen in PAM, which can be identified by using equalizers at the receiver end. The transmission bandwidth required for the PAM is related with the help of a sampling rate. The transmission bandwidth tau is less than the sampling rate, where the sampling rate is the duration sampling time of a pulsated signal. And in order to reconstruct an original message signal at the receiver side, it should satisfy the sampling condition. Fs should be greater than equal to 2 FM, that is 2 times of the modulating signal frequency. This sampling rate is always less than the reciprocal of 1 by 2 FM or reciprocal of 1 by 2 FM. From these expressions or inequations, the sampling time is less than transmission bandwidth is less than sampling time, which is less than reciprocal of 2 into FM. The on time and off time of an PAM signal will be given by Fmax is equal to 1 by 2 tau. Bandwidth is greater than Fmax. Therefore, bandwidth or the transmission bandwidth is greater than or equal to 1 by 2t is greater than 2 FM. This is what the transmission bandwidth of an PAM signal. So how this transmission of PAM signals can be done. For PAM signals to be transmitted, Through the free space, it requires antenna, which can be using amplitude, frequency or phase modulated by a high frequency carrier signal and then can be transmitted. This overall system can be written as pulse amplitude modulated AM or PAM FM, PM at the receiving end. First the detection of this PM signal is done, and then after the message signal is recovered from this PM signal is going to be taken place at the receiver side. Coming to the drawbacks of this PM, as we discussed earlier, bandwidth required for this PM is very large in compared to the different frequency modulation. Amplitude of PM varies accordance with the modulating signal, so there will be a chance of interference of noise, or as the noise can be included only in the amplitude parameter, so there will be a chance of interference of noise in PM signal. There will be a variation of peak power which can be required by the transmitter. Coming to demodulation of PAM. So in order to demodulate this message signal from PAM signal, at the receiver side a demodulator is required. And how it can be demodulated means simply by using a hold circuit and two different basic blocks called holding circuit and a low pass filter will produce the required message signal, which can be seen here. So it is going to make use of a reconstructing filter at the receiver side, and then it is passed through a low pass filter which exactly cuts off the frequency of Fs by 2. This is known as the reconstruction filter or interpolation filter. The low pass filter eliminates the high frequency ripples which are present in the modulator signal, and then it is applied to an inverted amplifier to amplify the signal level to have demodulated output which is almost equal to the amplitude of the message signal. So for a flat topped PM signal, first the received PM signal is given to a holding circuit, and the output of this holding circuit is given to a low pass filter which produces the demodulated signal in case of an PM. So this is what the circuit diagram of an zero holding circuit. So in this also it is going to have a switch where the switch is going to be closes after the arrival of pulse signal and opens after the ends of the pulse signal, and the capacitor C charges to the pulse and holds this value during the interval between the two pulses. So for example, if a PM signal is being given to this zero order holding circuit, so for the on time of first pulse, the switch will be in a closed position and the signal will be passing through capacitor and it will be holded there for the remaining half duration of the pulse signal. Once the second cycle of pulse started, again the switch will be in a closed position and starts passing. Okay. Charging and discharging of the circuit will be taken place. This holding circuit output may not be the smoothed version, so which can be smoothed by passing the output through the low pass filter. Here it is also called as a zero order holding circuit, which considers only the previous sample and decide the value between the two pulses. Whereas in some scenarios we can use higher order holding circuits. For example, if the first order holding circuits consider only the previous two samples, second order circuit considers only the previous three samples. In this way different orders can be used. That is about pulse amplitude modulation and demodulation techniques. Thank you.